Okay, this one. Students in a class are investigating spending in their local area. They each carry out a different survey and display the results. Okay, so a stats question from 2014. John is investigating whether people pay for their weekly shopping with credit card, debit card, cash, or check. When people tell him which one they usually use, he writes it in his table. His results are shown below. Fill in the frequency table below. Okay, so one way you can do this is with a tally score. So by that I mean, well, here I have a credit card, so I'm going to put a 1 under the credit card box. I then have a debit card, so 1 goes here. I have another debit card. I have a cash. I have a debit card. I have a credit card, cash and cash, so 2 more of these. A credit card, a debit card, a debit card. Then when you get to 5 with a tally, you put a line through the 4. So when you look at that, you now know that's a group of 5. A check, cash, cash, cash again, debit card, cash, and credit card. So looking at that, I have 4 credit card. I have 5 and 1 6 as debit. And this makes it really easy to count. So I have 5 and 2 7 cash, and I have 1 check. And I make sure I have them all accounted for. So 1 2 3 4, 1 2 3 4 5. So I have 20 in total. 6 and 4 10. Look at this. You see, I forgot these 2. Debit card goes here. Let me rub these all out again. Debit card goes here, and cash gets another 1 too. So let me do that again. So I have 1 2 3 4 credit cards, 7 debit cards, 5 6 7 8 cash, 1 check. Okay, and I add them up again now. 7 and 4 11, and 8 is 19, and there's my 20 accounted. So that's why it's really important to make sure that you've everybody accounted for. So I don't know how I missed them too, but I did miss them, but caught just by doing that quick check of making sure everything was all right. So my next one then. What is the mode of John's data? Okay, so the mode, what does that mean? So the mode is the value that occurs most often. Okay, so or the group that occurs most often. So when I look at this is the easiest place to see it now that we have it in our frequency table, which is the method of payment that occurred the most often. Well, you can clearly see now that it is that it's cash. Okay, so cash goes in here. John says that he cannot find the mean of his data. Explain why this is the case. So the mean then is another word for average. So our 3 measures of centre, the mean, the mode, and of course the median is the 3rd one. So the mean is the average. As John is saying, he cannot find the mean of his data. Well, average, how do we get that? We add up all the values and we divide by the number of numbers or the number of values. So they're not numbers, so I can't add them up. So that's why I can't get the mean. So they're not numbers. So cannot be added up. Okay, so let me go back to this again now, and I'll just clear this off so you can see it. If I ask you what type of data this is, I would be hoping you would tell me that it is categorical data, and it is categorical nominal data. Okay, so remember we've 2 types of categorical data. We have nominal data and ordinal data. And I remember categorical as words. Your answers are words for categorical data. And of course, the other type of data is numerical data. And I remember this one because it's numbers. Okay, so in numerical, you can have continuous numerical data, or you can have discrete numerical data. Continuous means it can have any value, the number, such as your height. Your height can be any value at all. Or you can have discrete numerical data. And discrete means it can only have set specific values. So for example, shoe size is 1. You can be 4, you can be 4.5, you can be 5, you can be 5.5, 6, but you can't be 5 and 1/4, you know, so there's set values for shoe size. Whereas continuous, as in height, you can be any value at all. Categorical ordinal data has an order. So for example, if I asked you what you did, how did you do in a test, and you answered for me A, B, C, D, or E, I immediately know who did the best, because there's a specific order to those letters in the context of a test. The A's did better than the B's. The C's did better than the E's. Okay. Whereas if I look at nominal data, such as this data here, there's not one of those methods better than the other. Okay, they have no order. It doesn't matter whether you say cash or credit card, there isn't one better than the other. Color of your eyes is another obvious one for nominal data. Okay, so where was I going with that? Well, you cannot get the mean, or the mean of categorical data, because it's not numbers. Okay, part 5 then, display John's data in a pie chart. Show all of your calculations clearly. Okay, so the data. I'm just going to copy this table here. I'm just going to paste it here for us. Okay, so that's our data that we're going to use to create our pie chart. Okay, so remember what a pie chart is. I'm going to draw a circle. Okay, and we're going to break it into slices of the pie, and the bigger the slice of the pie, the more often that method of payment occurred. Okay, so how do I work out the size of the angles? Well, you have to remember that everybody added up to 20, okay? There was 20 people asked. So then if I look at the credit card, 4 out of the 20 people chose credit card, which is a fifth, and I get a fifth of 360 degrees. Okay, 360 degrees is the number of degrees in a circle, or the number of degrees in a pie. So if a fifth of the people chose credit card, then I want a fifth of the pie to represent credit cards. Okay, so 20, I'm just putting this into the calculator, and I get 72 degrees for that one. Okay, and you work your way down through them all. So debit card then is 7 out of 20, and I get the same fraction of the pie as there was out of all the people who chose debit cards. So 7 over 20 multiplied by 360, so I'm getting 126 degrees for that one. Cash then, so I'm just working out all the angles first, and then I'll do the pie chart. So 8 over 20 multiplied by 360 degrees. So 144 degrees for that one. And then finally, where I might check, is 1 out of 20 multiplied by 360 degrees. And I'm getting 18 degrees for that one. Okay, so let me get my mat set, and I'm taking my protractor out of it. Okay, and of course I need to draw a starting line in my circle. So I'm imagining the center of my circle is there. You'll see the little hole from where you stuck in the needle of the compass, and we draw a starting line over there. So that's typically in a pie chart where we start drawing our angles from. So I put my protractor down, and you see the black line that runs on the bottom of your protractor, that should lie flush with that line I just drew. So that's that black line. It's not the bottom of your protractor, but it's the black line at the 0 degrees angles. Okay, and then the crosshairs, and the crosshairs are at 90 at the top. Those crosshairs should cross at that hole or that needle point of your protractor. Okay, so make sure the crosshairs, which is the point that goes up here to 90 degrees, is right bang there at the point of your or at the needle point of your circle. And we're going to draw our angle this way, and we always go anti-clockwise, or typically go anti-clockwise when you're drawing angles. So you're starting on the inner circle, which is the one that starts at 0. Okay, so I'm putting down my protractor now, and I'm going to measure out that 72 degrees for credit card. Okay, and I drew my circle up too high, so I'm going to have to move him down. So let me do that, because I can't put my tick mark in because I'm going off the page. Okay, so let me do it. Okay, it's just because I'm on a digital screen and it won't allow me to put a tick at the top. So 72 degrees is somewhere here. Okay, so from here up to that little tick mark, I draw in my line as such. Okay, so 72 degrees, and you put in what category it is. So it's credit card. Okay, and you can see that your 90-degree angle would have been, that's a 90-degree angle. So that looks about right for 72 degrees. Okay, I know you can't see it, but I'm now turning my screen across or around so that that line there now is where this one was. So I've just turned my screen around because that's now my next starting line for the debit card. So again, I put my protractor down so that the black line is flush along here. And now again, the crosshairs, the 90-degree crosshairs are right at this point here. Okay, so your crosshairs are right at that point there. What am I measuring this time? 126 degrees. So again, I'm measuring this way. So I'm starting at 0 degrees here. Now mine won't be the most accurate because the digital screen doesn't really like me leaning on top of it. But anyway, we'll work around that. So 126 degrees is somewhere out here. Okay, so you mark in your angle and you mark in the category. Okay, I swing my screen around again and I do it again for a cash. So 144 is what I'm doing this time. So 144 is over here. So join him up. So the purple line now was my starting point this time. So this one here was my starting line. And I measured 144 degrees around to that orange line. So I'll turn back my screen so I'm not writing upside down. So 144 degrees for that one, and that one's cash. Okay, and then you can measure the next one if you want, and you probably should, and make sure you're in and around the 18 degrees, that it's somewhere before the 20-degree line, and that's check. Okay, so there is your pie chart. And we've shown all the calculations clearly. So I do hope that makes sense. Okay, Margaret wants to examine if people prefer to do their weekly shopping in Tesco, Dunnes Stores, SuperValu or Lidl. So she stands outside her local little shop for one day and asks everybody as they leave the shop where they prefer to do their weekly shopping. Give one reason why Margaret's data may be biased. Well, the one big one that jumps out at me is where Margaret is when she asks the people. She's outside her local little shop, which means that the people she's going to ask, more than likely, are the ones that's coming out of Lidl after doing their shopping. So typically when people do their shopping then in Lidl, they prefer to do their shopping there because they're free to do it anywhere they want. So the majority of people, I would assume, that's going to answer her question is going to give Lidl as an answer. So therefore, we could say something like Margaret's data is biased because of where Margaret is when she does the survey. So she will most likely have most people answering Lidl as their favorite place to shop, as the people passing her are after coming out of Lidl shopping. Okay, so therefore, this is not what we call a representative survey or sample of shoppers. Okay, so what do I mean by representative sample? Well, it's not representing everybody who shops. So she's not capturing people, or more than likely is not capturing people who would prefer to shop in other supermarkets. So let's say something like that. Margaret should stand in a neutral spot, maybe outside Penny's. Okay, because Penny's is not a food shop, so it's a perfect place to take this survey. C, Mary is interested in the amount of money people spend on their weekly shopping. She surveys people as they leave the local supermarket on a Saturday morning and displays her results in the two graphs below. So we have a pie chart of money from anything from 0 to 10 up to 120 euros. So there's our pie chart, all the different segments of the pie. And we have the same data in a histogram with all the different bars representing the number of people who spend that amount on their shopping. Mary wants to show that about half of her sample spent less than 40 euros on their weekly shopping. Which graph do you think she should use? They spent less than 40. Okay, so let me colour in the section of the pie chart that's less than 40. So that would be everything from 0 to 40. Okay, that's easy to see that that's about half the pie. And then 0 to 40 here. Would be here, so it's not too often difficult to see it also there. But I think the pie chart is easier. So I think the pie chart for this question, give a reason it's easy to see that half the pie is less than 40 euros. Okay, I suppose the tail here on this one, the ones that pull you up, makes it a little bit harder to see if that's the other half in the histogram. Mary wants to show that there were more people in the 30 to 40 group than in any other. Okay. Okay, let me clear this out for a second. Let me copy the charts. Okay, Mary wants to show that there are more people in the 30 to 40. Okay, 30 to 40 is here than in any other group. Okay, or 30 to 40 is here. Right, which graph do you think she should use? Well, I think with the pie chart, it's kind of hard to see that this one is bigger than this one, because this 40 to 50 looks quite big as well. So I think they look about the same to me. So for that reason, I actually prefer the histogram to this one. And the reason I prefer the histogram is because it tells me the actual number of people on a histogram rather than the size of the angle. Okay, if I had the size of the angles here in the pie chart, then I could easily see this was the biggest slice of the pie. But I don't have the angles in the pie chart, but I do have the frequency or the number of people on the histogram. And you can see that that is clearly the highest bar. So the most people spent between 30 and 40 euros. Okay, so I would say this one, the histogram. It's clear that 30 to 40 is the highest bar, okay, with 20 people. Okay, in the pie chart, 30 to 40 and 40 to 50 look the same size, look like the same size or the same angle, or however you want to phrase it. Okay, so that was that 2014 question, was it? 2014 question.